In this question, we're asked to write the rate law for an elementary reaction. And you may recall an elementary reaction is a reaction that occurs in one step in order to go on to form products. So in this case, we have 2NO plus Br2 yields 2NOBr. So in order for this elementary reaction to occur, two NOs must collide together and with a Br2 at the same time. Said another way, this is a termolecular reaction. All three of these things need to collide at the same time. Because this is an elementary reaction, and only because this is an elementary reaction, we can write the rate law this way. Rate equals K1, because it told us to use K1 for the rate constant, concentration of NO squared, because there are two of them that are involved in the reaction, times the concentration of Br2. So, if you have an elementary reaction, you can use the reactants in order to write the rate law. So this is the same thing as the concentration of NO times the concentration of NO times the concentration of Br2, because you have two NOs and a Br2 that are all involved in the reaction. The higher the concentration of these things, the more chance that you're going to have an effective collision where all three interact at the same time and go on to form product. Note, and as I said before, you cannot write the rate law for this if you do not have an elementary reaction. If you have an overall reaction, which is very, very common, you can't simply just write these, you can't say that it's second order with respect to NO and first order with respect to Br2 just because there's two NO and one Br2 if it's not an elementary reaction. In that case, you would actually have to do some studies, like you will do in the lab, in order to determine the rate order with respect to those reactants.